Hey, what's up? It's your old pal, Mr. Cook, and we're going to do the Algebra 2 6.5 to 6.8 review. This is a preparation for the quiz that we're going to take on these topics in Unit 6. So this is all just log and exponent stuff. You need to know a couple of things. When we're working through these, especially the expand and condense, you need to know 3 log properties. You need to know the log property of when logs are adding together, like if I have log of x plus the log of y, that's equal to the log of x times y. So they combine from 2 logs into 1, and vice versa. If it's 1 log and it's multiplying, it expands to 2 logs. If we have 2 logs that are multiplying, like log x minus log y, this is the same as saying combining them together to make 1 log of x over y, x divided by y. And then the last one is if we have some number x multiplying times the log of y. This is the same exact thing as saying log of y to the power of x. It basically brings the x in as an exponent for y. So I'm going to use these 3 log properties over and over again for the first 8 problems. So that's what this video is going to center around, just those 8 problems here. Okay, so first it tells me to expand, so I'm taking single logs, like the ones on the right-hand side here, and I'm expanding them out into multiple logs and multiples of logs. So first thing that you're going to want to get rid of is any multiplication or division that's going on, so any multiplying or dividing. So you're going to use these ones first when you're expanding. So I notice that I have some multiplication here and here, so that means that these 3 things that are multiplying together are going to split off into 3 separate logs. X is going to have its own log, y is going to have its own log, and z to the 4th is going to have its own log as well. So it looks something like this. Log base 7 of x plus log base 7 of y plus log base 7 of z to the 4th power. So that's what happens when we use multiplication inside of a log. It turns into addition outside the logs. There's one more thing that we need to concern ourselves with, and that's this power that's in here. We're going to use this rule, and whenever you have a power, it gets moved to the front of the log. So this gets moved to the front of this log over here, and we get log base 7 of x plus log base 7 of y plus, and then the 4 moves out front, so 4 log base 7 of z. This has been fully expanded into individual logs that are either adding or subtracting, with any exponents being moved to the front. Okay, number 2. So we have 2 values that are dividing. So division turns into subtraction between the logs. And notice that the one that's in the denominator is the one that you're subtracting away. So to get rid of the division here, this becomes log base 2 of x to the 6th power minus log base 2 of y to the 3rd power. Now we've subtracted the logs, so we got rid of this division. Now we got to get rid of these exponents, and do you remember where the exponents go? That's right, they move to the front of the log. So both of these are going to move to the front of their respective logarithms, and this becomes 6 times the log base 2 of x minus 3 times the log base 2 of y. So that's fully expanded out logarithms, and there's only values that are left inside the parentheses. All right, so the same thing goes here. We're going to do one little trick first, and this helps out, I think, an awful lot when we're working on our logs. You can just distribute the 2 in as a power to both of these. So then this becomes log base 5 of u to the 4th squared. You multiply the 4 and the 2 together, and you get u to the 8th power. And then v is v to the 1st, and then 1 times 2 is 2, so that turns into v squared in the bottom. Then this problem looks an awful lot like the second problem, so we're going to do the exact same steps that we did with it. So the division turns into subtraction between the logs. So we have log base 5 of u to the 8th minus log base 5 of v to the 2nd, and then just move your exponents out to the front, and you're all done. So we have from this one 8 times the log base 5 of u minus 2, because the 2 moves to the front, log base 5 of v. And there's our answer for number 3. Number 4 is only tricky because of that square root that's right there. The square root, when you have a square root, it's really just to the 1/2 power. So I'm just going to rewrite this. This is the same thing as saying log base 5 of z times, and then that's going to be the square root of x, so x to the 1/2, because square root is the 1/2 power, and then times y to the 1/2 power. Now this becomes just like number 1, very similar to that, where it's 3 things that are multiplying, and then you move to the powers to the front. So the multiplication turns to addition, so I rewrite this as log base 5 of z plus log base 5 of x to the 1/2 plus log base 5 of y to the 1/2. Then I move the powers out to the front of the log, and I'll be all done expanding. So I've got log base 5 of z plus 1/2 log base 5 of x plus, then the 1/2 moves out front, 1/2 log base 5 of y. And this is the simplified expanded expression. So that's it for the first 4 problems. Now let's go ahead and do the other part of it, which is condensing. I personally think condensing is a lot easier than expanding, because all you have to do is just start by moving any exponents in, and then it's just using these properties to turn it into one single log. So it's actually pretty easy. For number 5, we have 2 natural logs, and we have a number that's multiplying up front for each of them, so those go inside the logs as exponents. So that means that this becomes natural log of x to the 4th plus natural log of y to the 6th. Now since they're adding together, we can combine them together to make one log that's multiplying the 2 numbers together. So that means that this is going to turn into the natural log of, and then I'm going to multiply these 2 together, so x to the 4th times y to the 6th, and just like that, I'm done. And the same thing is going to be true for all these. Just, move your exponents in for number 6 and number 7, and then just combine them together using, either of these rules here. So let's try number 6. Move the exponents in, so we have log base 8 of x to the 3rd minus log base 8 of y to the 2nd power, and then subtraction combines together to make one log that divides. And remember that the negative one is going to go in the denominator. So that means that this turns into log base 8 of x to the 3rd goes on top, and y to the 2nd power goes in the bottom in the denominator. And we're all done with number 6. For number 7, again, the exponents move inside the logs, and they become powers. So this becomes log base 6 of x to the 6th minus log base 6 of y to the 12th. And then we combine these together, so subtraction turns into division. So this becomes log base 6 of, and then it's going to be x to the 6th over y to the 12th. And we can just leave it like that. It's all done. So for this one, what I'm going to do is distribute in the 1/2 power to each of these. So the 1/2 is going to go into both of these. So I'm just going to rewrite it real quick. This becomes log base 4 of c minus 1/2 log base 14. No, that should be a 4. That's probably typo 4. So log base 4 of a, and then negative 1/2 times 1 is going to be a negative 1/2, so minus 1/2 log base 4 of b. So I'm going to have to write that kind of small. Sorry about that. So log base 4 of b. There we go. Now, just like what we did with the other stuff, just move the exponent in to the logs. So I'll try and write this a little bit bigger. I apologize for that. Log base 4 of c minus, and then the 1/2 goes in there, so we have log base 4 of a to the 1/2 power, and then minus, and then the 1/2 is going to move in on the b as well, so we have log base 4 of b to the 1/2, and then we just need to combine all this stuff together. And so remember what I said about the negatives. The negative log goes in the denominator, so both of these are going to go in the denominator for our fraction. So this combines to make one log that looks like this. Log base 4 of, the c is going to be the only thing that's in the numerator. And then in the denominator, I've got a to the 1/2 and b to the 1/2. And if you were in my class, that'd be as far as you need to go. But Some are going to require you to write that as a square root. Now just, this can easily turn into a times b and then the square root of that. So you can write those either way, and that would be your answer for that. Okay, so these are the first 8 problems on the quiz review. And if you need a little bit more help with them, these are in 6.5. So make sure that you check out those sections if you need a little bit of additional help. All right, so on to the next video. We're going to work on the rest of the first page here and probably into the second page as well through number 20. All right, that's it. See you on the next video.